Welcome back everybody to Geology 101. In this unit we're going to cover faults and folds. Faults we've talked about before, a little bit about what they are, and here we're going to talk about why they happen, what makes them happen, and maybe a little bit about where they happen. We'll also talk about this thing you can see in the background, this thing called a fold. So let's get started. So in order to understand why rocks change shape, why they deform, we have to understand this thing called pressure. Okay, well it's maybe not pressure exactly, it's really this thing called stress. Now, pressure is one kind of stress. We have a force, some kind of a push or a pull, acting on a surface. So pressure, you imagine that you take a cube of rock and put it at the bottom of the ocean, and the weight of all the water on top of it is going to press it in from every side. This is one kind of stress, but you can also imagine something that was the opposite, right? We take the rock and we start pulling it apart in every direction. This would be another kind of stress. And finally, we might take the rock and we try to rotate it. We push one side this way and pull the other side this way. We get our final kind of stress there. So these three types of stress have names. We have tensional stress, we're pulling outward, compressional stress, where we're pushing inward, and then shear stress, where we're rotating. We have a stress that acts in a direction that is parallel to the surface of the rock, like in the image here. So whenever you apply stress to a rock, the rock changes shape, and this is called strain. So stress is the force put on it. The response of the rock is the strain response. Now, look at the diagram here. You don't have to worry about getting all the details. What I want you to imagine, right, is we have slowly increasing stress and strain on something like a rubber band, right? We take a rubber band and we're stretching it out. And at first, when we just stretch it out a little bit, if we let go of it, it'll snap back right where it was before, no change in shape. But if we keep stretching it out more and more, eventually we will pass what is called the elastic limit. So it no longer behaves in an elastic way once we have put too much stress on it. Instead, once you stretch it out a little bit more, it starts to change shape permanently. So you let go of the rubber band and you look at it now and it's stretched out. It's a different shape than it was before. And if you kept pulling on it, even after it started to get stretched out, and you pulled more and more and more, eventually it would fracture, it would break, and the same exact thing happens in rocks. So let's break these individual parts down. First we have elastic deformation. You pull the rubber band out a little bit, you release it, and it snaps back. This is a temporary change in shape. And the same is true not just of a rubber band, but also something like a paperclip. You stretch it out a little to hold some paper, you take the paperclip away, and then it goes back to the same shape that it was in before. So that was elastic deformation, but what if we kept stretching the rubber band out? Once we go past the elastic limit, we hit the zone of ductile deformation. So ductile deformation is a permanent change in shape. It doesn't rebound totally where it was before whenever you stop applying stress, right? We've taken the paper clip and we're using it to hold a ton of paper. Now the shape is changed permanently. The same thing that you might see in a rock like this. Finally, if you put too much stress on something, it will break, and this is brittle deformation. We have a permanent change in shape or material breaks or cracks. So let's say that I told you I was trying to break a rock and you wanted to know what the result was. You would ask me some questions, right? You would want to know how hot the rock is. Is it room temperature or was it heated up? You would want to know how much pressure, how much force is being applied to the rock. You would want to know how quickly that force is being applied, slowly over long periods of time or all at once. And finally, you would want to know what kind of rock we're talking about. So we've talked about stress and applying force to rock. But as a geologist, you don't get to see the stress happen. Instead, you go out into the field, you see that rocks have been deformed, maybe in the form of a fault, and you have to work backwards from what you see to determine the kind of stress that was applied, and that's what we'll do in the next section.